Hello geographers, and welcome to this video as part of your natural hazards topic. This is lesson number 1, which serves as a bit of an introduction into the following things. We're going to be looking at what a natural hazard is today, so you should have a definition and some examples of hazards. We're going to be thinking about the factors that affect hazard risk, so make hazards potentially more severe. And we're also going to start having a look at the location or distribution of your first type of hazard in your topic, which is tectonic ones. So volcanoes and earthquakes, where they are, and we'll have a brief introduction into the concept of tectonic plates. So the first thing we need to be working on is just making sure that you know what a natural hazard is. And in your workbook, as you can see here, you have got a definition. So the definition reads a naturally occurring event which has an impact on people. There needs to be an interaction with people and or property for it to be a hazard. So it's worth noting, as shown in this Venn diagram here, that there must be an overlap between nature and people for it to be considered as hazard. If you are looking at a volcano or perhaps an earthquake or some sort of storm that's happening in the middle of nowhere with no people or population, then we would still consider that a natural event, not a hazard. It only becomes a hazard when you've got people involved in it, and therefore we would then class it as a natural hazard, not just a natural event. So what I'm going to get you to do now is just think of some examples of types of hazards, and we're going to categorise them into atmospheric and tectonic and geological. So atmospheric is obviously anything that involves the atmosphere. So often this is going to be things associated with weather and in particular extreme weather. Tectonic and geological is anything that is happening on the surface of the Earth, so upon our tectonic plates, and can also be due to changes or movements in any sort of landmass or sediment. So what I would like you to do is just have a bit of a think about those and just pop some ideas into those table sections for me now. I've got this diagram here where obviously the names of all of the hazards have been blocked out, but it might be helpful in helping you to determine some examples of each of these types of hazards. So pause this video now. Come up with a list of as many atmospheric and as many geological hazards as you possibly can, and then after that you can unpause the video. I'll reveal what's underneath each of these blue boxes and we can just check that you've got a nice clear list. Okay, so having a little look at these are all of the things that were covered up in that previous slide. You can see on the left-hand side that all of those things there are atmospheric because they are to do with weather. And on the right-hand side, you can see that these are all involving the movement of sediment or the movement of tectonic plates. So as a list, you should have something that looks a little bit like this. We have got all of those extreme conditions in terms of weather on the left, so hurricanes, snow, drought, all of those things could potentially create a hazard if they are in a location where there's a population. And on the right-hand side, we've got everything from those hazards we know well from disaster movies, so volcanoes and earthquakes and tsunamis, but also things that involve movement of sediment, such as a mud flow or a landslide, can be classed as a hazard if, as I said, there are people in the area. So what we're going to do now is have a think about what actually makes these hazards worse. And to do that, we need to think about this idea of a hazard risk. So to define hazard risk, it's the chance or probability of being affected by a natural event. And there are lots of things that are going to increase the severity or likelihood of hazards becoming quite catastrophic. So we'll look at some examples here today. The first one we've got is urbanisation. So urbanisation is obviously the increase in the proportion of people living in cities compared to those living in rural areas. And if we've got high population densities like this, then this could make pretty much every type of hazard worse. And we'll be thinking about why shortly. We've then got poverty. Now, unfortunately, poverty exacerbates and makes worse pretty much every other factor of life, and hazards are no exception there. So if you've got an area facing hazards such as volcanoes, earthquakes, tsunamis, hurricanes, then poverty is going to make that hazard risk far greater for those people. Unfortunately, we also must consider climate change. So climate change is obviously something that we now accept is happening. There are very few climate change skeptics left in the world. And unfortunately, one of the leading bits of evidence that we have got a change in our climate is the increase in extreme weather. And of course, as we know from that previous slide, then that is going to create potential natural hazards. So climate change existing and worsening in the first place has got the potential to make hazard risk even worse. And the final one is perception of risk. So with this one, to perceive something is to think about how you view it. So, for example, we could even take the current coronavirus pandemic, though not a natural hazard as we are going to study within this topic. We have different levels of the perception of risk across our population. There are some people at the moment who are very worried, and there may be certain factors which mean that that is very justified, or it might be that they just have an increased sense of fear. So they are going to be staying at home a lot more at the moment and perhaps being a little bit more worried as they listen into the news. There'll be people on the other end of that scale who have a much lower or at ease perception of risk in terms of this pandemic. They might be of the view that if it happens to them, they'll be fine, or maybe even it's not going to happen to me, or it's not important, and therefore their perception of risk is going to be different as well. Now, those two people are going to be acting differently, aren't they? And they're going to be effectively putting themselves at more or less risk because of the way that they see the risk itself. And with natural hazards, that is very much the case as well. There are some people that think that volcanoes, for example, are an act of God, and they will potentially just deal with the consequences if they should happen. And then there's other people that are much more cautious. So what we're going to do is we are going to have a little bit of a look at this part of your booklet now, where you're going to hopefully try and explain how each of these 4 factors could lead to an increase in the severity or impact of a hazard. So in simple speak, how might each of these things make a hazard worse? Okay, so what I've done for you is just create some really simple sentence starters that you can choose to use if you need a little bit of help kicking off with this activity. But what I would like you to do is just pause this video now and try and fill in that table the best you possibly can to explain how each of these things are going to make the hazard worse. I'll give you a few moments, but you, of course, are definitely advised to pause here as well before we go through the answers on screen, because it's important that you are stretching those brains to think about your own ideas before we go through answers. Off you go, and come back to me when you're ready to go through some ideas. Okay, so let's go through some of the things you could have written. There will be other things you could say here, of course, but we just need to make sure that as a group, we have got some examples. So to begin with, we just need to think about urbanisation. So urbanisation obviously involves quite a dense population, and the higher the population, the greater the number of people at risk from a natural event. So this is going to increase fatalities, it's going to increase pressure on the emergency services. There's lots of things, knock-on impacts that you could talk about just from simply having more people in an area. Now, poverty, as I said, unfortunately exacerbates many other issues, so makes things worse. And if we think about that in terms of natural hazards, then one of the things that could be linked to poverty is people being in the area in the first place. If you are somebody that is struggling for money and you need either a house to live in or a plot of land to farm, then you may be forced to live in areas that are unsafe because it's likely that those areas are cheaper. Now, an example of this is Lima in Peru, because there's a shortage of housing. So people are having to build their own very unconsolidated houses. So, not your typical one with really good foundations, perhaps more almost slum-like, if you can recall that from your urban topics. And not only are they creating those types of buildings, but they're being forced to build on some really, really unstable slopes around the area. And what that means is that whenever there is heavy rainfall, those areas will be prone to flooding and landslides, and potentially putting those people in quite grave danger. So even just poverty itself is going to make the issue worse. But don't forget as well that if people are already malnourished, if people are uneducated and therefore don't know how to react or what to do, if they don't have savings to rebuild, then of course all of those things and many other things linked to poverty will make the hazard worse. Okay, so climate change. Now this one is generally going to create more extreme temperature changes, and in many parts of the world that means that we are getting warmer temperatures, not just of the atmosphere, but also of things such as the sea surface temperatures. So what that means is that the energy within the atmosphere is going to increase because things that are warmer have more energy. And then also we're going to get increased evaporation from the seas, which is going to increase the chances and also strength of any tropical storms that occur. And then also, of course, we've got increased temperatures leading to things like droughts. So warmer temperatures is definitely something that we're a little bit worried about in the context of climate change. And then if we think about this perception of risk, obviously we spoke about the COVID pandemic as an example, but we must think about this, of course, in the context of natural hazards, is we need to just think about how people react if they are fearful or perhaps slightly blasé about things. So if somebody has a very high perception of risk, if they're very fearful, then they're more likely to do one of the following things. They might move away, which you could say is actually going to reduce the level of risk because those people aren't going to be there anymore. Or what they can also do is they can reduce the risk by doing something about it. So Japan, for example, are very conscious of their risk of earthquakes, so they have got earthquake-proof buildings. Whereas if there are other countries or parts of the world where maybe that level of risk perception, so how worried people are, is less, and that could be due to lots of things. It can be cultural, it can be that the people haven't known a volcano to go off in that area, for example, or maybe it's a religious thing. So like I said earlier, some cultures and religions will accept that if these things happen, they happen and they were supposed to happen. So what that means is these people are less likely to move away, and they're also less likely to prepare themselves for the hazards that they may be potentially facing in the future. So that's going to increase the severity of the risk and the hazard once it does happen. So that section there marks the end of the introduction of what a hazard is. So what we now need to do is just start getting you set up with an understanding of tectonic hazards, because this is going to be the first part of your natural hazards topic. So looking at this picture, I'm sure this map is something you have seen before, all the way back in year 9, and it's something that geographers find quite interesting. So you may recall it from your year 9 lessons. What we're going to do now is we're just going to think about the distribution of volcanoes and earthquakes. And here you can see that there is a 3-mark question, which is similar to what you might get in your exam. Now, looking at this map before we start, it's worth noting what everything is. So the yellow lines are obviously going to be quite significant, but then we've also got the red triangles, which are volcanic eruptions, and the dark greeny blue dots, which are earthquakes. So what we're going to do now is just think about the distribution of those red triangles, the volcanoes, and the dot earthquakes, so that we can effectively work towards some statements that would get you some marks in the question above. In your booklet, you have an activity which will help you do this. So we're not going to write it as an exam question. You can just annotate. You can see that one of these has been done for you already. So you can see here that there is a mention of a cluster of earthquakes and volcanoes running down the west coast of South America, where the Nazca and South American plates meet in countries such as Peru and Chile. So what I would like you to do is try and do that exact same thing. Notice something about the map. It could be a trend or an anomaly, and you're going to annotate an example of where that's the case on the map, and hopefully also give some examples of countries at the very least, but if not, it would be really great if you could also be trying to work out, which coastline, for example, it is, use the compass points, or even think about the names of the plates. Now, obviously, they're not on this particular map, but you would be able to find those quite easily with a Google search of a tectonic map with plate names on it. So pause this video now, give this a go, and then when you're ready, you are going to unpause and we'll go through some examples together. Okay, so some of the things you could have written, of course, these are only examples. You may have come up with something equally, valid, but obviously we don't have time to look at an entire global stretch of trends here. So one thing you could have spotted here is that most volcanoes and earthquakes exist in lines along the edge of plate margins. So here, this is probably the thing that most students note within the question that you saw in the previous slide. But what would make it even better is if you've got some examples. So for example, there are lots around the Pacific Ocean, and we know that this is referred to as the Pacific Ring of Fire. You might also notice that as well as that general trend of them occurring in these linear patterns, there are some anomalies. So you could talk about how these earthquakes seem to be more likely to occur away from the plate boundaries than volcanic eruptions. So looking at those triangles, you can spot that most of them tend to be quite close to those yellow lines, which we understand are plate margins. But the dots, the earthquakes, seem to happen more frequently than volcanoes away from the plates. So that could be something you can mention. And then just picking an example, you could have used the centre of the Pacific Ocean. Here, for example, we can see that we've got some in the kind of Central and Northern Europe, which is quite far away from any of the plate margins across and along the edges of the Eurasian plate. Something else you might have noticed as well are some anomalies in terms of the volcanoes, and this one here is Hawaii in the middle of the Pacific. And for anybody that remembers their studies of Year 9, you may know that that's because this is a hotspot. Don't worry too much if you don't know that, because this is not an activity that asks you to explain. So you would probably get the marks there for just talking about the fact there are some volcanoes found in the middle of plates and then giving the example of Hawaii. So here are the plates. If you wanted to get some extra detail onto your map in your activity previous to this, then you could maybe be putting some of these on there. Like I said, I mentioned the Eurasian plate, which is the green one that we sit on, but there's lots of other plates as well. These are the major plates. It's worth noting that this is a very simplistic version of reality. In reality, there are hundreds of tiny little tectonic plates that make up our crust. So assuming you remember that part from Year 9, obviously our crust is the most outermost part of our Earth structure, and it's broken into lots of separate bits of crust that we call tectonic plates. Speaking of Year 9, I am interested to see if you remember the following things associated with the layers of the Earth and the general structure of our planet. So I'm going to just show you now 4 questions, and I'd like you to pause this video and just see if you can recall any of them. Can you remember any of these answers based on your Year 9 studies of Angry Earth, where you did end up focusing on volcanoes, but the first part of it was definitely about tectonics in general? Pause this video now. You don't need to write things down, but just have a little bit of thinking time, and then unpause, ready for a bit of a recap of these 4 areas of tectonics. Okay, so let's go through some of those answers. So we had those 4 questions, and the first one was 2 types of crust. So when we think about these tectonic plates, we classify them according to whether they are oceanic or continental. So the Pacific plate, for example, being mostly underneath the Pacific Ocean, is oceanic, and then the continental crust, for example, would be the Eurasian plate that we're sat on. We're going to look at this in a bit more depth in a moment. Thinking about what causes the plates to move, now there are lots of other things at play, which if you decide to join us for A-level geography, you will learn all about. But we understand and have understood for the longest time, out of all of the mechanisms, that convection currents are driving movements in the plates. So to make them move around and bash into each other and move away from each other in all of the ways that you'll be looking at in the next lesson. Speaking of the next lesson, you're going to be looking at this bit too. 3 types of tectonic plate margins you might remember as constructive, destructive and conservative. And then also, finally, we've just got the awareness that things aren't as clear-cut and simple as things only occurring on plate margins. Earthquakes, for example, can occur due to other things. They can actually be man-made if we are completing processes such as fracking and looking for oil underground. They can also just be a bit of a kind of stress release for the crust, because remember, plates are moving, so it might be somewhere in the middle of the plate, a bit of tension is built up that needs released. But generally those earthquakes aren't as big as the ones we get on the plate margins, which is why thankfully the UK rarely experiences anything that is felt significantly by humans. So let's have a little bit of a think about the general structure of the Earth. Again, trying to recall a little bit from your Year 9. What I'm also going to do is I'm going to put into the description box of this video below a grade booster video that's made by Time for Geography, which is an excellent online resource that we've used a lot over our GCSE lessons at the Thomas Hardy School. This one is actually perhaps a little bit beyond GCSE at times, but if you fancy taking as much as you can from it, or even boosting your understanding beyond what is expected at GCSE, then you can pause this video now and watch it. Otherwise, I'm hoping that you might be able to do this without any further visual support, because you've got a simple sentence finisher or fill in the gap activity in your booklet that's exactly the same as this one. The words are in the yellow at the top, so pause this activity now on the screen, give it a go, and when you're ready to check your answers, then unpause and we'll go through those together. Okay, so let's read this through. Heat from the core creates convection currents in the mantle. This causes the magma in the mantle to rise until it reaches the crust. So it's worth remembering that hot rock will rise above anything that is cooler than it because it is less dense. And that's causing this kind of upwelling. As you can see in this diagram, it's named upwelling here, of magma in the mantle, and that is effectively the first part of the process. Let's continue with this activity. As it can't break through the crust, it separates and flows underneath the crust. So here in this diagram you can see that just underneath the crust we've got movement directly parallel, haven't we, underneath it. Now that rock is actually going to be dragging the plates along with it a little bit through the process of friction. Eventually, the magma cools and sinks back down into the mantle. So obviously it's further away from the core, which is the heat source of this whole process. So this magma, as it reaches the top of the mantle, the closest to us, is going to cool down a little bit. And as it cools, it becomes heavier and it sinks back down. And as you can see in this diagram, this is a very cyclical process. It's almost like a cycle that continues and recycles and repeats. And it's really, really important in the movement of our plates on the surface. Okay, so the next thing we're going to have a little look at is the oceanic and continental crust types and the differences between them. So before I go through anything with you on here, I'd like you to use this diagram here as a little bit of a hint to see if you can start writing down anything that you notice that is different about the oceanic crust, which is the one on the left, and the continental crust, which is on the right. You're going to just pause this video now to give yourself again a little bit of thinking space, and you're welcome to be jotting down those ideas into your table that's below this in your activity workbook, and then we'll go through some ideas together in a moment. Okay, so hopefully you've paused that and you've given this a go. You've also still got that diagram in your booklet to refer to as I'm going through some of the things that you could have written, and hopefully we're going to go through some things you haven't written as well so that you can add them to your notes as we discuss them. So the first one is pretty obvious. The oceanic crust is generally found underneath oceans. For a reason we'll talk about in a minute, it's quite new in terms of geological time. 200 million years might not sound like that long, that new, but actually in geological timeframes, remember that the planet is 4.6 billion years old. That's actually quite new material. Something to note is that it's denser, so you might have spotted that because it seems to be kind of more sunken down into the mantle than the continental crust. So it's heavier and it's going to be kind of compressing down onto the mantle a little bit more than continental crust. As a result of that, when it does meet another plate at a plate boundary, it can actually subduct. It will sink down because it's heavier. Now, one thing to note is that actually the reason why oceanic crust is so new is because it's constantly being destroyed and remade. So thinking about that image that you can see in the diagram mentioned in the previous slide, you can see that the oceanic crust is being shoved underneath the continental crust. And some of you might remember that that's a destructive plate boundary. So it's going to be actually melting that part of the plate away. Now, that doesn't mean that our planet is getting bigger or smaller, because on the other side of that plate, there will be a spreading at a plate margin, and then new oceanic crust will be created. Next lesson, you will look at constructive plate margins and understand that a bit better. But the main thing to remember is that oceanic crust can be almost reborn, and then it can also be destroyed at a destructive plate margin, which is why it's new, because it's constantly recycled. If we think about the contrast to that for continents and continental crust, you can basically just flip a lot of those things. So look how much older this continental crust is on average, 1,500 million years old. It's less dense and can't sink. So looking at that diagram, what you might notice is it not only is it thicker, but it's actually higher up. And the reason for that is it's a lot more buoyant, a bit like an iceberg. It floats on the mantle instead of compressing it. So because it floats and because it's not as dense, it means that actually continental crust cannot be destroyed. It's never going to sink underneath another plate and therefore can't be renewed and can't be destroyed. Okay, so we're going to just now have a little bit of a think about some facts about the things we've spoken about today, and I'm going to now display all of these. There should be 10 of them, and I'm going to ask you now again for the final time to just pause this video and see if you can work out whether these statements are true or false. You've got some rough notes areas in the back of your hazards book, but of course you can just be jotting this down on any scrap of paper, 1 to 10 down the margin, and a T for true and an F for false. Pause this video now, test your understanding, and once you're ready to go through those answers, unpause and we'll go through them together. Okay, so here we go. Question or statement number 1, 4 layers of the Earth. That is true. We've got the inner core, outer core, mantle and crust. Some of you might remember a rap from your year 9 memories to help you remember those. The mantle is a solid rock is false. It's not actually as runny and liquidy as a lot of people think, but it is still classed as liquid rock. It's sometimes closer to the crust, a bit more elastic, but generally we consider it to be liquid. Another false is that the crust, that should say the crust is one unbroken layer. So we now know obviously that there are the main plates and there are hundreds of little plates as well. Convection currents don't happen in the core. They are driven by the core and the heat that comes from it, but they happen in the mantle. Another false, oceanic crust is not older than continental crust. It's continuously being renewed and destroyed. Continental crust is thicker. That's true. Continental crust is not heavier or denser. Remember, we spoke about how it kind of floats a little bit like an iceberg on top of the mantle. It is not as dense as oceanic. Another false, lots of falses today. So continental crust cannot be renewed and destroyed because it's not heavy enough to be sent underneath another plate. This is a bit of a tricky one because we haven't actually mentioned this, but I wanted to get your brains working a little bit as we come to a close this lesson. So plates can contain both types of crust is actually true. Like I said, a lot of models and theories and things like this in geography are oversimplified so that we can at least understand things a bit better in a very messy, complex world. Some plates can have a little bit of oceanic crust on them, but if they're mostly continental, for example, it will be a continental plate. And the last is false. Earthquakes and volcanoes can happen away from plate boundaries, and you're going to look into some of those reasons why as you start moving through the process of learning about these tectonic hazards. So here marks the end of our lesson 1 on natural hazards, and hopefully you are happy with what a natural hazard is, some of the factors such as poverty and climate change that could make a hazard and the hazard risk worse, and we've also made sure that we've got a clear understanding of where volcanoes and earthquakes are located, with some understanding of tectonics in the context of oceanic and continental crust. So next lesson, what you will be doing is you'll be looking at those plate margins and what can happen on each type of plate margin. So thank you very much for watching through lesson 1, and we look forward to seeing you back on our YouTube channel for your second video, which is going to be on plate margins. Thank you very much, geographers. Have a brilliant day.